All right, here's a simple kind of overview of stoichiometry and chemical reactions. So stoichiometry is just relating one reactant to another reactant or product or vice versa. So we can start with product and go to the other product or reactant. All right, so it's just relating these. At the basic level, we look at the mole to mole ratio, but often, like we're going to see in a minute, we're going to need to go grams. All right, so the kind of normal stoichiometry calculation you want to be able to do is to go from grams of A to grams of B. All right. So what that means is in this example here, I could go to grams of this to grams of this, or grams of this to this, or any of those other permutations. So let's look at how we do that. Well, first of all, we need the balanced equation. A lot of times you start with that. Sometimes you're given it in prompt like this, and it says here that ethanol reacts with combustion. That means reacts with oxygen to produce carbon dioxide and water. So you would take those words and those formulas and put them in here, and then you would balance it. All right, after you balance it, what it's telling you is one molecule of ethanol reacts with three molecules of oxygen to produce two molecules of CO2 and three molecules of H2O. So molecules works, but it's often not very convenient. A more convenient one then is going to be moles, and it's the exact same ratio, right? Because we can just multiply by or divide by Avogadro's number to go from molecules to moles. It's the same number. All right. So let's look at then that equality that happens. That balanced equation is giving us then the quality you will use in your dimensional analysis. So we can relate from CO2 to ethanol or vice versa. All right. These are saying that these are equal. And so if we put one on top, one on the bottom, we can relate between them. All right, it seems kind of weird, but let's look at it. If we start with 3 moles of ethanol, how much CO2 can we produce? So we start with what's given, 3 moles of ethanol. We put down, we know we want to get rid of the moles of ethanol, so we're going to put that on the bottom. We know we want to get to CO2, so we put that on top. And then afterwards, we come and we just match up the number that's in front of the ethanol in the balanced equation. And we look at the number in front of the CO2 for that. All right. And so then when we multiply, we can see the units cancel, and that gives us. And notice we have the exact same ratio, right? We still have 1 to 2 ratio. It's just we're starting with 3, not with 1. So that's the kind of basic level, mole to mole, but often we actually get to grams, all right? That's the kind of heart of it. So if we take this reaction and we look at how we go from grams, let's say we have 16 grams of nitric acid, and we want to figure out how many grams of barium nitrate we have. So what do? Well, we have to go from grams to moles, and we do that using the molecular weight, all right? That number always comes from a periodic table, just adding up. And we always use the subscripts. We don't include the coefficients there. The coefficients are always used in the mole to mole ratio. So these numbers always come from the balanced equation, the coefficients in there. So grams of nitrate on the bottom, we get the molar mass, and it's always 1 mole. These moles always comes from periodic table. And again, we want to get the grams of barium nitrate. So we're going to have moles. We want to get rid of it. And we're going to get back to grams. And notice it's inverse between these two. All right. And then we can see how the units cancel. And it should say grams of barium nitrate. All right. That's what we're actually getting. So that's the standard stoichiometry kind of calculation. Once you have this, then setting up this full dimensional analysis will allow you to do gravimetric, volumetric, limiting reagent, excess reagent, theoretical yield. All those concepts build off this. So you want to make sure you get this strong fundamentals for stoichiometry.